Hello everyone, my name is Luca, and I'm an astronomy and aeronautics student at Lick-Wilmerding High School. I'm making this short video series to teach you about the universe, how it works, and some ways that you can interact with it and experience it from home. In the last video, we learned about telescopes, and even made our own one. In this video, we're going to talk about light, how it's produced and moves, and some phenomenon that might occur with light. Light is caused by electromagnetic waves, which are also known as EM waves for short. EM waves cover a lot of different types of waves, including microwaves, which are the waves that the common kitchen appliance uses to heat your food, X-rays, infrared rays, and many more. Visible light is just one of these different variants, and the difference between the variants is a difference in wavelength. An easy way to visualize wavelength is if we imagine the ocean waves. Wavelength is the distance between the peaks of the waves. So, as you may know, magnetic forces have a positive and negative pole. Electricity also works the same way and has a negative and a positive charge. EM waves are created when either the magnetic force or the electric force starts to change from positive to negative continuously, and we call this oscillating. And this constant change creates a change in the opposite force. So if the electric force, the electric field, starts to oscillate from negative to positive continuously, then the magnetic field will also start to oscillate from negative to positive, as you can see in this image. Now, you may have heard of the speed of light before. The speed of light is the fastest that an object can move in the universe. And contrary to the name, it applies to all EM waves. So all EM waves move at the speed of light. And the speed of light is actually 299,792,458 meters per second. But it's usually rounded to 3 million meters per second. And although speed on the highway, as you might see, is usually measured in miles per hour, in science, we like to use the metric system, which means measuring things in meters or kilometers or anything like that. Another scientific concept we use is scientific notation. Scientific notation eliminates the amount of zeros we need to use. So for the speed of light, for example, we have 8 zeros after the 3's, 3 million, and then there's 3 and 8 zeros before you get to your decimal place. So we can eliminate this number of zeros, and we can write the speed of light as 3 times 10 to the 8th meters per second. This is just a basic lesson on scientific notation, so you can sort of recognize what these numbers mean when you're looking at them. Now, because light takes so much time to travel, although it's pretty quick, it does take a good amount of time for things that are very far away. So it actually takes 8 minutes for the light from the sun to reach Earth and for us to observe it. So when we see a sunset or sunrise, we are actually looking at the sun's position from 8 minutes ago. This concept allows us to see back in time, kind of. So for stars and galaxies that are light years away, we can see the light happening and changing billions of years after it actually happens. So this allows scientists to answer questions about how the universe first began by looking at the light that's incoming from billions of years of traveling. Now, light can be a very hard concept to grasp because you can't really see it moving and it just sort of exists. But if you think about it as any other object, but a very small and fast version, it can be easier to visualize this. So imagine the photon, which is the particle that light is. So when you're seeing light, you're seeing the photon. If you imagine it as like a baseball, and when you're playing baseball, you only feel the baseball hit your glove once it's made the impact. So similar for light, you only see the light once the photon has hit your eye. And so this is the same for light, but light just moves much, much faster. Thank you all for checking out my video on light. In my next video, I'm going to talk about the solar system and our own planet Earth, and that's going to be my final video, so make sure you watch it.